Good morning, everyone on my part as well. I will present you the new data collection study that was performed in Cyprus under the project QUALICHeCK and show you the results of the observations we made on heat transmission coefficients compliance in Cyprus. Summer comfort is extremely essential in Cyprus as the high temperatures experienced during the summer sometimes reach at around 40 to 43 degrees Celsius. Moreover, we have diurnal temperature variations that occur from the highs and lows during the day, which make the need for the thermal control of the building necessary. The first national requirements for the U values in Cyprus came into effect in 2007, and the result was making the insulation of a building mandatory. An important revision of those national requirements came in 2010, which had as a result the compliance with a maximum average U value and a minimum accepted energy efficiency, category B, in the energy performance certificate of the building. And then we had another important revision in 2013, where new maximum specified U values were specified for the external walls, columns, and beams, for the external exposed floors and roofs, for the floors above spaces without air conditioning, and for the external openings. Also, we had a new U maximum average U value for the envelope of the building. The U value is the inverse sum of the resistances of each building material and surface resistances to the outer and inner faces of the build-up of an element, as you can see here in the figure as well. Non-compliance with input data leads to wrong reporting, and reported U values may vary from actual U values due to various reasons. For example, during the energy performance certificate calculations, the qualified experts may be applying same U values for construction elements with different U values. Or, during construction, there may be use of different products with worse U values than the ones specified during the energy performance certificate calculations. Also, there may be mistakes or omissions of building elements during construction, which lead to a different U value than the one stated in the energy performance certificate. There may be missing or unclear definition regarding the input data, for example, for windows and doors. Moreover, although in Cyprus there is a control framework regarding the calculations, as the calculations are submitted to the authorities for the issuance of a building permit, there is no control framework on site. All the above have as a result that the reported performance of a building is better than the actual performance. The new data collection study in Cyprus focused on 27 newly built residential buildings, which were all well-documented buildings in different areas of Cyprus. The collection of the relevant information and the on-site visits took place by the 31st of July 2015, and the report was available by the 7th of August 2015. The information that was collected during this study was design documentation, the as stated in the energy performance certificate U values for the shell and frames and the average U value of a building, photographs of the examined buildings during construction phase, and documents from suppliers regarding the U values of specific elements. Moreover, we communicated with the architect and tenants to check the actual construction of various elements and calculate their U values, and performed site visits and inspections to check the actual construction. The study aims to provide answers to the following questions. The first question is how well new requirements regarding maximum U values and maximum average U value have been followed both in design and construction. The second is what percentage of the residential building from those examined actually comply with those regulations. The third question is in case of non-compliance of maximum U values and maximum average U value with the requirements in actual construction, whether there are specific elements that do not comply. And finally, in case of non-compliance with maximum U values and maximum average U value with the requirements in actual construction, whether there is a pattern of causes for this. It's worth mentioning some of the statements which were made by the qualified building energy assessors who declined to provide any information regarding either all or some of their energy performance certificates. One of the statements was, I know that some of the residential properties have not been constructed as specified, and one of the reasons is that there was not a supervising engineer on site during construction, as the properties were owned by a developer. Another answer was that alterations were made during construction, but some of the energy performance certificates were not revised due to time and budget reasons. And a third statement was that when information was asked by the engineers of the project regarding the building elements, they said to proceed with the same calculations regarding those elements as the one usually made in other projects. The study found that there were deviations between calculated in the energy performance certificate U values and in actual U values. And here in the graph you can see the reasons for these deviations. One of the reasons was that there was no reliable input database, or an external element like an exposed floor slab was not taken into account. Moreover, there may be application of the same U values in the energy performance certificate for construction elements with different U values. We found also calculation mistakes and changes that were made during constructions that were not revised in the energy performance certificate. Finally, materials were omitted in calculations. And only in one out of the 27 properties which were examined, no problem was found. So coming back to the questions that we said earlier, the first question, how well new requirements regarding maximum U values and maximum average U value have been followed both in design and construction? And the answer is that only in specific construction elements in 10 out of 27 examined residential properties they have not been followed. The second question, what percentage of the residential properties from those examined comply with those regulations? The answer is that only 63% of the examined residential properties fully comply. The third question, in case of non-compliance of maximum U values and maximum average U value with the requirements in actual construction, are there specific elements that do not comply? And the answer was that in most cases, exposed floor slabs or external openings or columns, pins, and shear walls were the elements that did not comply with the regulations. And finally, the last question, in case of non-compliance of maximum U values and maximum average U value with the requirements in actual construction, is there a pattern of causes for this? And we found that this was due in most cases due to lack of knowledge, with the result construction elements not taken into account, changes during construction which were not taken into account in the energy performance certificate, as there was no revision of the energy performance certificate after construction, application of the same U values for construction elements with different ones for simplification. And the conclusions of the new data collection study in Cyprus were the following. The main reason that requested information was not provided by some qualified experts was that the reported in the energy performance certificate U values vary from the actual U values. The causes for this were either lack of a supervising engineer on site, as the property was owned by a developer, alterations made during construction without the relevant revision of the energy performance certificate due to time or budget reasons, and an engineer giving wrong or deficient information to the qualified expert due to lack of knowledge or appreciation of the value of the energy performance certificate. But even in the 27 examined residential properties where information was provided by the qualified experts, which are the best cases, there are still deviations between reported and actual U values, which sometimes are not so important, for example, during calculation and construction element like the code CIME being omitted, but which sometimes are very important, for example, no reliable input database, construction elements like a whole exposed slab or single glazed windows being omitted during calculations, and changes during construction without the relevant energy performance certificate revision. Thank you all for your attention.